the author of 2 books, and National Geographic's done 3 documentaries on my work. Discovery Channel's done 1. We're currently in the process of an IMAX movie covering the work that I'm doing with black bears. But despite all that, it hasn't been easy, and the things that haven't happened is the scientific community, the scientific writers, haven't grasped onto any of my work. I've written about them in all my books. I've mostly anecdotes I've told because, you know, people aren't interested in charts and graphs. And so I'll go take you through the journey, which started when I was very young. I had interests which are very much the same as they are today. I had a plan. I knew what I wanted to do, and I knew how I wanted to do it. It kind of started out with my father, Lawrence Kilham, who was a virologist at the Dartmouth Medical School, and he studied birds as an avocation. He went to school and grew up at a time. He died in 2000 at age 90. I don't think he ever heard the word dyslexia. I suspect he was dyslexic. He annotated all the books that he read. I do the same thing. He read very slowly. He would meet with my mother and have a cocktail in the evening and repeat and recite everything that he read that day. And I think that was his way of remembering everything. He also structured his life so that every minute of the day was planned. He did a certain amount of the same thing, whether it was watching birds or writing in his notebooks or writing journal articles. And he was very productive. He published 125 journal articles in virology and another 125 in ornithology, and wrote 4 books. And I grew up helping him with his bird work and understanding how he did things. And then I went to school, you know, from this child who already had an idea of what he wanted to do and how he wanted to do it. And in school, I learned that I couldn't do any of those things. I learned that science wasn't about going out and observing things and documenting what you saw and writing about what you saw. Science was about keeping track of quantitative numbers and using statistics and doing all the things I couldn't do at all. I literally was not capable of calculus. I wasn't capable of reading quickly. I didn't understand the scientific method, but I understood what I wanted to do, and I knew how I wanted to do it. And my life with dyslexia, you know, obviously started with school. I got some help early on. I flunked out of kindergarten. That's a common story around here. I had a speech difficulty. I couldn't say CH or SCH. My mother put me in a private school that was run by retired teachers, and they used puppets as the principal and all the administrators in the school. And I was taught how to speak. And it was a 2-year school, so in 3rd grade I was mainstreamed back into regular classes. I was an all right student. I was a C student, sometimes a D student, but you know, I got by. And my dad expected that I would go to college. He didn't care where I went to college or what I studied, but I went to the University of New Hampshire and I studied wildlife, and I studied wildlife because I already knew it. I already knew all the birds, all the trees, all the plants, where birds nested, all the mammals. All I had to learn was Latin names, and that wasn't that complicated. The first 2 years, however, were liberal arts, and I almost flunked out. The last 2 years, I got pretty good grades and ended up with a B- average or something like that. I'd hoped to go on to graduate school to do the kind of work I'm doing today, but the graduate schools that I were at the time wanted 1,400 or better in GREs, and while I did well in biology, I got a 400 in English, and I wasn't accepted in any of the graduate schools. But my other interest was in mechanical things. My favorite toy when I was 2 years old was a vacuum cleaner. And at that age, I was disassembling my older brother's models. I was taking things apart all around the house. And I was, you know, at that very young age, wanting to know how things worked. And unfortunately, I was good at taking them apart and not very good at putting them back together. So I decided after college and not getting into graduate school, I decided to go to a trade school and learn the art of gunsmithing. And I'd been interested in guns. I started my first business at age 16. I started a gun shop. My mother got a federal license, and I was selling firearms and hunting equipment in the basement of my house. I was interested in target shooting and gunsmithing, and I was still destroying guns for not knowing what I was doing with them. But when I got to trade school, I learned very quickly that I was very good with my hands. And I got through the trade school in a quicker time. It was go at your own rate. It was a 1.5-year course, and I graduated in 10 months. And my first job was with Griffin and Howe, which was Abercrombie and Fitch's gunsmiths, very highly, at the time, before they went bankrupt, was a very high-class gunsmithing outfit. I then worked for Griffin to Paul Yeager's in Philadelphia, which was another old European gunsmithing company building high-grade custom rifles. I worked for a custom pistol smithing outfit in New Jersey, and finally went to work for Colt Firearms and Product Engineering, where I met my wife Debbie, who's sitting out in the crowd. I was at Colt Firearms for 2 years, but I was able to get a new product onto the market, something that very rarely happened with any of the employees. And I was able to do it because I could read how the company worked. And at the time, it was run by bean counters. Excuse the language if anybody's an accountant in the crowd, but the bean counters had taken over the company, and they controlled every part of the company. So they didn't know anything about the product, and each of the parts of the company, the manufacturing and product engineering and quality control, all became power centers. So if a new product came up, one of them was going to kill it, just because they could. And so I realized that this is how it worked, and that if I had anything new in this design, and it was to make the 1911 pistol, which was their standard bearer, a modern gun for combat shooting, the new type of target practice, I went back into the old blueprints, and I found all the pieces that I need to make that gun modern in old blueprints that I knew they could already make because they'd already made them. And the only new piece was the rear sight. And I made a model of this gun and presented it to them. And it made it onto the market. It sold out immediately. It had effect on all the sales since then. And I asked, I said, you know, I put a lot of money on the bottom line, and I said, well, how about a raise? And I was being paid the minimum rate because I was a gunsmith, not an engineer. And they said, well, you have to go back to school or be here longer. And of course, neither of those were options. In 1982, we came back to New Hampshire, and I still had it in my mind that I wanted to do the kind of work I wanted to do. And I started my own business as a custom gunsmith, which gave me the freedom to spend the time studying bears. And bears just came to us accidentally. I wanted to study a carnivore, and my dad studied birds. Birds were relatively easy to study. He prided himself on simple apparatus. He had a pair of binoculars and a small folding chair, and he and my mother would sit in front of woodpecker nests and document courtship and behavior. But carnivores were a bit of a problem because they disappear rapidly into the underbrush, and you don't get much of an opportunity to study their behavior. But based on my childhood experience, my dad brought a lot of wild animals into the house. When I was 2, he went on sabbatical to Africa and brought a half-grown leopard into the house, much to my mother's chagrin. My younger sister Phoebe, who helps me with bears today, was 1 at the time, and my next oldest brother Josh was 4. He woke up one night with a leopard at the end of his bed screaming. But needless to say, we all survived and returned from Africa with 2 African hornbills and a Nile crocodile that my dad raised in a basement shower until it was 6 feet long and the National Zoo had to come and take it away. In 1961, we came to New Hampshire for the first time. When I was 9 years old, my dad still had animals around the house. He had a blanket license to keep any native wildlife. He had woodpeckers and aviaries, crows and ravens, hawks and owls. He had a fox in his study. We had a beaver in the kitchen that dammed up the toilet and leveled out the kitchen floor. So, you know, I grew up with quite an experience. So based on my childhood experience, I realized I could raise an orphan animal loose in the forest, acting as a surrogate mother, and document its juvenile behavior and use that to understand its adult behavior. And again, I wasn't thinking about black bears because there was no formal rehabilitation of black bears at the time in most of New England. I was thinking about a fox, or a coyote or a bobcat, or perhaps a fisher, the large woodland weasel we have around there. My sister Phoebe and I became wildlife rehabilitators. She was good with husbandry. I was interested in behavior. And at the end of 2 years, none of those animals came our way. But accidentally, a conservation officer brought us an 11-month-old black bear cub, which was quickly confiscated from us. It had a congenital disease. And later that spring, the director called me back and said, "Would you take the animal back?" And we did, and ultimately we had to euthanize, and we found out what the ailment was. But later that spring, I got a call from another biologist in Vermont, and he had 2 orphan cubs, and asked me if I would take those cubs. And I said I would, as long as I could get a permit. And I said, would you contact New Hampshire, and if they give me a permit, I'll take the cubs. Well, the next morning I had a permit in the hand, and since that time we've raised, rehabilitated, and returned to the wild 130 black bear cubs. I build all my process on first-hand information. I've realized that what I see, I can build models of, and I can build very accurate models of. And what I read so slowly I can't make any sense out of anything. And I've realized that over time that all of the written word is full of inaccuracies that you can drive trucks through. But what you see with your own eyes is reality, and reality models very, very well. But I realized that in studying bears that an animal like the bear, the only information it has is first-hand information and its own experience. And it lives or dies based on that information. And I realized that we evolved using that kind of high-quality information. And the written word is only, the spoken word is only 40,000 years old, and the written word is only 5,000 years old. And sometime in that period, it has corrupted everything that we speak to and relate to each other. And so I suspect that we evolved to be dyslexic. And then after the written word came along, suddenly the people who could count beans got the power and were more successful than those of us who did things by first-hand observation. I build on an understanding, and I can read and stick things to my understanding. But if I read something strange, like I read a sports article or an article on politics, I don't remember it. It just goes flying by. And if I read something really strange, like, the comprehension in GRE tests and stuff like that, I can't even remember at the bottom of the page what was said on those things. That kind of information doesn't stick at all. I have to glue it to something I'm terribly interested and passionate about. I use a systems approach. I see everything in this world as a system. And because of that, a system can be solved. It's a puzzle. And if you can find enough pieces, you can start to form a model that you can understand the system with. I think in pictures, not words. I have a photographic memory of what I see. When I got my first set of cubs, I would take them on long walks in the forest. I wouldn't take any notes. I'd come back and then I'd write up my field notes. And when I wrote up my field notes, whether it was that evening or the next morning, I'd turn on a video. I'd re-walk the walk. Everything I paid attention to on the walk was right there in vivid video in my head. I'd write down everything that I saw, and I had a very nice, concise set of field notes. Many of those notes I can still see in my head. I can turn those videos back on and re-watch them. And I was also a believer in results over representation, and unfortunately school is all about representation. You've got to produce those equations to show what you did. So my abilities have been to observe and model real information, to model and manipulate pictures in my head, in 3 dimensions in my head. I did all my mechanical design by loading pictures of parts of firearms in my head and then assembling them, manipulating them, changing angles of sears and strengths of materials. And then when I got all done and had a working mechanism, I'd go build it, and it would be right. I have the ability to simplify and reduce complexity. I love problem solving, inventing, and predicting. All those things I was good at, but unfortunately, I couldn't. I wasn't a good salesman. I wasn't a good money raiser. I wasn't good at all the other things that it takes to be successful with that kind of stuff. So I moved on. This next slide I stuck in there. What happens to smart kids who don't get equal opportunities, equal educational opportunities? They choose a life of crime. They become a terrorist. They become an artist or a tradesperson, or they study bears. I chose to study bears. The cubs that I worked with to do my research are these very young cubs, the bottle feeders that come to me that are dependent on us. As I say, we've raised a lot of bears. Some years we've had as many as 30 bears at one time. We raise them in an 8-acre forested enclosure. These are very intelligent animals. As I said, my interest is in behavior, and when I started working with black bears, they were considered to be solitary animals. That is, the only interactions they had with each other and their own kind was with their mothers and cubs and their mates. They knew they congregated at concentrated food sources, but beyond that, they knew very little about them. And what I've found is they're highly social animals. This is my representation of the bear's social behavior. You won't be able to read it from that distance, but you can see it's very complex, and it's surrounded by pictures. And the pictures are pictures of the bears doing what I say they're doing in the chart. And what I found is that black bears are highly social animals, but they're not social in the way we think of a social animal. We think of a group of chimpanzees or a pack of wolves that have fixed territories with family units living within them. They have alpha animals that allocate resources down through the family groups. The closest thing the black bear has to a territory is the female home range. She's relatively territorial over that. She needs 3 to 8 square miles of a high-quality home range to raise her cubs, primarily because her cubs have short legs. And these female home ranges are evenly spaced on the landscape in a cookie-cutter fashion. The foods of the black bear are the highest quality foods in the forest, the nuts, berries, and ants, bees, and grubs. These foods are generally available in patches. They're affected by the weather and seasonal availability. So at any given time, one female bear may have a huge surplus of food in her home range, and her immediate neighbor could have nothing. And this has led to a system of sharing over time that I believe that these bears are reciprocal altruists, that they share a common social behavior with humans. And this is something that has not been found in any other non-human animal. It's what they've looked for in the great apes, but the great apes are all territorial with social family units living within it. Bears on a regular basis communicate and cooperate with strangers. As I say, I started working with the cubs that came to me before they had experience with their mothers outside their natural dens. I decided they needed an opportunity to learn, and I needed an opportunity to learn as well. I took them for long walks in the forest, up to 9 hours at a time, and returned them safely to remote enclosures. I observed their very first reaction to their natural environment. I saw their tongues coming out and lifting scent off an object in a very exaggerated fashion. They'd pull the scent back and they offer it to a small bump behind their front teeth. This bump was called the papilla of the vomeronasal organ. Bears, like your cats and dogs at home, have 2 olfactory systems: the vomeronasal system that identifies new scent, and the nasal epithelium that learns from the vomeronasal system and is able to locate and later identify scent. This same behavior in adult bears is almost impossible to observe. It's very subtle, very quick, and as I say, it just looks like random mouth movements. I followed several of these bears into adulthood. One of them, the main bear that I work with, is this bear. Her name is Squirty. Squirty came to me as a 7-week-old cub that weighed 3 pounds. I walked her in the forest. I followed her into adulthood, going in on her telemetry signal and traveling with her during the day. Squirty not only established her own home range, but currently, as she expanded a home range, she dropped a daughter into the expanded area and now controls a greater home range that she shares with a number of adult daughters and granddaughters. And Squirty today, she's about to go to den. She'll be 20 years old in January and will give birth to her 10th litter of cubs. Squirty currently manages her greater home range using a matrilinear hierarchy. And this is matriarch, her oldest daughter SQ2, another adult daughter SNLO, a younger daughter Brooke, another adult granddaughter 2, and a young subadult SQ2LO. Squirty on sight will chase all the members of her hierarchy below her in the hierarchy. It's linear because SQ2 will chase everybody below her, SNLO will chase everybody below her, and everybody chases SQ2LO. The result of that hierarchy is that in a marginal food year, Squirty will have access to the highest quality foods in the greater home range. The second thing it does, it allows these subadults a place to stay until they have a home range of their own, but they won't be able to reproduce until they do, or there's an exceptional food year. Because they're being chased all the time, they rarely get a chance to put on enough weight to reproduce. The young males that came into my study area were quickly chased out. This is Squirty going after her grandson. I watched this guy get chased more than 30 times, not only by his grandmother, but by his mother, by his aunts, and any other bear that could lock a target on him. And finally, by September of his second year, he left the greater home range and joined the population of male bears in the Upper Valley. In this video, SQ2LO, that subadult, who's now an adult, is going after a male bear and asking him to leave. The large males that came into my study area, and I'll take a moment to explain my study area. It's on a piece of property that Debbie and I own, a 400-acre piece of property that's surrounded by 65,000 contiguous acres of forest. I drive up there every evening from the time the snow leaves in the spring until it returns in the fall, unless I have a speaking engagement where my sister covers for me. I'm interested in social interactions, how bears chase each other and what it all means, and that's what I'm talking about tonight. I'm currently a PhD candidate at Drexel University. I'll be defending my thesis in December. And my thesis is on the social behavior of bears. I've documented over 1,500 social interactions that break down into the categories that I'm talking about tonight. These large males, which are the 300-plus pound animals, they dominate all the breeding. They suppress the younger males. And after the breeding season, they'd hang around and they'd take food from the females. Because of their size, they could take food from whoever they liked. But it wasn't long before the females decided this wasn't such a good idea, and they would ask them to leave. And in this picture, Squirty, weighing about 175 pounds, is going after a 350-pound male and asking him to leave. I watched her daughter, SQ2, and she weighed only 135 pounds, do a very stiff-legged walk, slowly zigzagging in front of a big 350-pound male. He backed off into the bushes and acted like it was no big deal. But in the morning, he was gone, and he never returned. And this suggests that there's a degree of female choice in mating, because if there wasn't a repercussion, these big males would stay and compete with the females in the female home ranges. The big surprise in my study was that there was a number of unrelated females that came into the center to my study area, which was in the core of Squirty's home range. She controlled the bears who had access to that home range, which was mostly her family members. They chased out the males, and she allowed this group of unrelated females access to her surplus foods and she showed very little aggression towards them whatsoever. This suggested reciprocity, and it also made me think that these bears were very different from other animals. If these females were enemies, she could chase them out and there would be no repercussion. But these females obviously were cooperators with her. They were all relatives of this bear, a bear named Moose, and Moose is 13 years Squirty's senior. And when Squirty first went out there, when I first released her into the wild, I took the cubs up in the early spring. I took them up on the mountain where I expected to find wild bears. They marked all the way up. The next morning they went back. I went back up. I had a collar on one of the cubs. I went back up the next day. Normally I could call them up and they'd come eagerly to me. They ran, which suggested they were with a wild bear. So I decided the next morning I'd go up on the signal and sneak in on them with the wind right, and I did this. And I broke a stick on the way in. My cubs treed and started moaning because I was a stranger. This wild female, which turned out to be Moose, ran to the base of the tree the cubs were up. She false charged me, defending my cubs from me. And then she ran off. They moaned again, and she came back and did the same thing. And then finally they got my scent. They changed their moan to a moan of recognition. And she went off and stood on a hillside. They came down and came up to me, and promptly each one of them bit me on my forearm, punishing me for interfering with their social interactions. This relationship has continued, and Squirty has established this reciprocal relationship with Moose and her clan. Squirty controls an oak ridge. Moose and her clan control 23,000 acres of beach to the east of the oak ridge. In years when there is no beach and only oak, Moose and her clan are on the oak ridge and at the clearing. And in years when there's no oak and only beach, Squirty and her clan can go into Moose's home range. So it minimizes the amount of aggression. I also learned about social contracts from Squirty. I set up an experiment duplicating an experiment done by Wolfgang Kohler in the 1920s. He studied chimpanzees, and he was interested in insight and tool use. And he hung food out of reach and scattered some boxes around. And he wanted to see if the chimps had the insight to stack the boxes up and get the food. And ultimately they did, but it took an awful long time. I didn't have any great expectations of bears, but I knew that they were insightful. I knew from experience that if you want a bear on your roof, all you have to do is put a bird feeder on your roof. And so when I set up this experiment, I had a remote camera filming it that would run for 2 minutes. The first bear in was Squirty's daughter, Snowy. She came in and she stood up. This is Squirty. She stood up underneath the bag. She flexed her knees and jumped a little bit and determined she couldn't reach the bag. In the 2 minutes the camera was on, she climbed the tree, grabbed the rope in her mouth, snapped it 3 times, and the rope broke off and she got the corn. The next bear in was her daughter, SNLO, who was a subadult at the time. And SNLO stood on the box, leapt for the corn, missed it, and then in the 2 minutes the camera was on, climbed the tree, went arm over arm down the rope, grabbed the bag of corn, and dropped off and got the bag of corn. Well, I was there when Squirty came in, and Squirty is different than any other bear that I work with. Because I raise Squirty, Squirty treats me like a bear. And for sometimes that's not so good, but sometimes it's given me insight about bear behavior that I couldn't get any other way. And Squirty came in, and here she is looking up at the bag of corn. She went to the box. She started rolling it in the wrong direction, biting big splinters out of it. She went over to my remote camera and started messing with that. She came back to my truck and put both paws over the mirror of the truck, started rocking the truck, looking up at me as though she could rip the mirror off the truck. I knew she could because she'd done it on a previous occasion. She'd taken both mirrors off. And so I exclaimed, "No," and she responded and went back to my remote camera and messed with that. And then she came back to me. She did a mock bite at my knee, and then she bit me on the knee, and I produced a bag of corn. And I realized right then and there that Squirty and I had a contract, and I'd broken the rules. And that was moralistic aggression. And I realized that Squirty, I had expectations of Squirty's behavior. I expected to interfere with her life, to be able to document what was going on. And she had expectations of my behavior. She expected that I wouldn't interfere with her social interactions, that I'd behave myself, and I'd give her her food, and it would be a nice reciprocal relationship. And when I broke the rules, I got bit. And then right after that, she went into a soft, repetitive moan of reconciliation. She said, "I'm terribly sorry, but that was necessary." And I realized that there was a parallel in all this behavior and human behavior. Because if you think about it, we're much harsher with our family members than we are with strangers. And we're harsh with our family members because they're our closest cooperators. And it's terribly important that we communicate with them. Now, unfortunately, how we communicate is not always pretty. And we can get away with it because we can always reconcile with a family member. But you never go up to a stranger and berate them the same way you might a family member, because a stranger is also a cooperator. And with a stranger, you might not be able to reconcile. And at some point in your future, that stranger might be important in your survival. The male bear strategy was a little harder to figure out. Male bears are harder to study than female bears. If you put telemetry collars or GPS collars on female bears, they stay in their home ranges throughout their life. You can always find them. A male bear's home range is up to 200 square miles. They can be in New Hampshire one day, Vermont the next, and Quebec a few days later, and so forth. So early in my study, I tried tracking them. That didn't work very well. And I had noticed that there was a high concentration of bears in surplus areas of surplus foods throughout the female home ranges. And I wanted to know what was going on. So finally, when trail cameras became available, I started monitoring the surplus bears in the female home ranges using trail cameras. And I'd put a small amount of corn in front of a camera, and within a 2-week period, I could usually get pictures of 8 or 10 different males in one of these surplus areas. But they didn't tell me what was going on. I literally took 75,000 to 100,000 pictures before I started to make sense out of what happened. And in 2008, I had the perfect circumstance. It was a clear cut that was 16 years old, right at the end of its productivity. The berries were diminishing, the insects were almost gone. And I got my 8 or 10 different males. When I set my cameras up in 2009, the only bear there was the resident female. The males had all moved on to another area surplus. But the big surprise was in 2008, I had an awful lot of pictures of 2 males in front of the camera sharing that small amount of corn. The amount of corn was enough that one bear could eat easily. And I realized that these bears had formed friendships or coalitions. And the male bear strategy was to form a loose group of unrelated friends to move in and overpower the females to access surplus food in the female home ranges. Again, this isn't reciprocal altruism. It's probably mutualism, but it's still between unrelated individuals. And I know these individuals are unrelated because I've done the pedigree of the animals in my study area. We use hair snares and collect hair samples wherever we can. I've had the pedigree done at the UNH Genome Lab, so I know who's related to who and whatnot. So with this complex social behavior, one would expect complex communication, and the bears have it. Squirty in this picture is opening and closing her mouth, expelling moist air out of her lungs, extracting scent from the air and bringing it back through her olfactory system. One of the things I discovered about the bear was that that bears, I knew they had the vomeronasal organ, which typically lifts large molecules of scent with saliva, but I discovered they also had an accessory organ that allowed them to identify aromatic compounds. And I discovered this because the cubs that I raised, all the green vegetation that went into their mouths, they would hold in their mouth for a few seconds and release. And I thought this behavior was pretty strange. I had a couple Brittany Spaniels at the time, so I stuck leaves in their mouths, and they weren't very impressed. I put leaves in my own mouth, and no bells and whistles went off. So I started documenting all the different plants, learning first what the plants were, and then documenting all the different plants that went into the cub's mouth. And over the course of the first summer, the cubs had identified 125 different food items and rejected many, many more. And I determined that a bear could determine whether a plant was edible or not simply by holding it in its mouth for a few seconds. And this led credence to the fact that the Native Americans credited the black bear. They observed the black bear to find out what plants could be used for foods and pharmaceuticals. Most of the plants out there are drop deadly or will give you serious problems. Then when I did the dissection, because I figured there had to be an organ there that allowed for this, I found a fatty organ about the size of a bean in their vomer. The vomer is a V-shaped bone that runs under the navel septum. There was a pocket in the vomer. There was a sensory nerve going down to the roof of the mouth. And then there was a bundle of sensory nerves that went up the vomer, under the brain, and spread out over the roof of the throat. And I'd also observed that bears reacted emotionally to scent. And it turns out that all the bears' long-range communication is done with scent. Many times I've seen Squirty getting a puff of scent on the wind, and she'd get a big smile on her face, and then 10 or 15 minutes later, her mate would show up, and she already knew who he was. And I've seen her on other times get a puff of scent on the wind and start false charging, swatting, and carrying on. And it would be a bear she didn't know or didn't trust, again, who was 10 or 15 minutes away. Well, bears also have emotional expression, which is generally honest. Social animals need to be able to communicate their mood. They have to know the emotional state. Emotional expression is facial expression, body language, intensity of vocalizations. As humans, we have the most complex facial expressions of any mammal on Earth. We have over 3,000 muscles in our face devoted to expression. We wouldn't be able to meet in this room if we weren't comfortable with the emotional state of everybody else in this room. And that's written all over our face. Right now, everybody in this room has a neutral look on their face, something I call subway face. Anywhere you go in the world and ride a subway, you'll see that expression. But if somebody were up to something in this room, we'd all know it immediately. We wouldn't know what he was up to, but we'd know who he was, and we'd know that he was up to something, because that also would be written all over his face. The Boston bombers were caught that way. They reviewed the video, and they saw these two guys walking off casually while everybody else was horrified. So it's a very reliable method. In this picture, Squirty has just put one of her cubs up a tree at weaning time. She has an aggravated look on her face. She has eye expression, eyebrow expression, general facial expression, and ear expression. When her ears are pinned, she's aggravated like a deer or a horse. And in this picture, she has a happy face. Now, I get told lots of bear stories by lots of people, and I often ask them what the bear looked like. And the answer I always get, it was black. Well, most scientists believe that all non-human animals communicate with emotion. That is, they cry out and others hear them. But black bears also have the expression of intention. And if you think about our language is an emotional utterance with mechanical manipulation of our lips, teeth, tongue, and larynx. So we can lie with our words, but we rely on facial expressions, body language, intonation of voice to determine if somebody is lying or not. The bears, when they communicate with intention, they mechanically generate sounds and actions. So now they chomp their teeth, they huff, they swat, they false charge, they make a guttural sound, a ho, which is a negative sound. And the meaning of these sounds and actions is based on the context of the situation at the time. So even though they're limited in the number of ways they can communicate, they greatly broaden it with context. Now, a false charge, which is rushing at you and swatting the ground and expelling a big blast of air, is pretty exciting when it happens to you. But if you were walking along a trail and you ran across a female bear and her cubs were already up a tree, she might false charge you. She sees you as the aggressor, and she's trying to delay confrontation long enough for communication to take place. Black bears operate on our level of emotional communication. 85% of how we communicate with each other every day is with emotional communication. Only 15% is language. Unfortunately, language is so powerful that all of our emotional communication is largely done subconsciously, the sending and receiving of signals. So a bear can read what we're up to, and we think the bear is from Mars. And so a lot of what I do is try to educate people on the meaning of the bear's communication. Now, it's based on context, so if you're working at a restaurant and you're carrying a pail of food scraps out to the dumpster and a bear false charges you, it simply wants you to drop the pail of food scraps before you put it in the dumpster. I was with Squirty one afternoon. It was a nice sunny day in New Hampshire, and this thunderhead came rumbling up the valley. Squirty false charged the thunderhead. And believe it or not, the thunderhead turned and the sun came back out. Well, here's a video of Squirty false charging. And I'm not doing it to scare you to death or trying to keep you out of the woods or anything like that. I filmed this with a handheld camera on the last film that National Geographic did on me, A Man Among Bears. The film crew showed up and they expected to work for 8 hours. Squirty showed up and thought about 40 minutes was appropriate. And this is Squirty telling the film crew to pack their bags and go home. Because bears are altruists, they also have a judicial system. Squirty manages her social hierarchy. She has expectations of the other bears in the hierarchy, and if they don't live up to her expectations, she punishes them. In the bears, we think we have a pretty good judicial system, but the bears' judicial system is far superior to our own. We have DNA and fingerprinting. We think it's pretty hot stuff. We've got to get it off the perpetrator. We've got to find it at the crime scene, and then we've got to find the perpetrator. Rarely do all those things come together. When one bear breaks another bear's rules, it knows who broke his rules, and it can track it down and exact punishment at any time. There's a transparency about bears. Wherever they travel, wherever their fur touches any object or the ground, it deposits a little bit of scent that another bear can follow for 48 hours or more. So in the bear's world, it would be like us being born with a GPS chip in our neck when we're at birth, and the NSA could track us throughout our life, making sure we did nothing wrong. Bears also follow each other to find food because they feed at concentrated food sources. One bear finds food, he travels off, another bear finds his scat, identifies what's in it, follows its scent back to the food source, and that's one of the primary ways that they communicate food sources. Bears are also deliberate markers. In this picture, you might argue that the bear in the upper picture, who's sliding under a sapling, in doing so, she's depositing sebaceous oil on that sapling. Sebaceous oil is like the oil in our hair. It carries large molecules of scent that have very little smell, but they're long-lasting. You might argue that she's not doing it on purpose, but this bear is a different bear, the same sapling, and this bear's got the sapling over her head and she's going like this, making sure she gets every bit of that sebaceous oil on the sapling. And the meaning of these marks is also based on context. So if we go in the woods and we find bear sign, all we can do is speculate as to what it means. If we see a bear marking, it means a little more to us, but the bears know what it means. And in this video, Squirty's daughter, SQ2, is following her mate, following that transparent scent. She wants to hook back up with him. So she's marking over his scent, hoping that he'll cross that scent trail and realize that she's trying to reconnect. She's using her olfactory abilities to determine everywhere he travels. And she back rubbed on the tree. And now she's going down everywhere his feet touch the ground. You can see her mouth movements. And now she's going to do a funny stiff-legged walk, disrupting the soil under her feet, leaving a symbolic message. She'll be marking with urine, which lets him know who she is. And finally, she's going to walk over a sapling, which picks up scent from her underbelly and flips up behind her like an olfactory antenna. So these bears are very busy communicating with each other and deliberately marking in the forest. This is a 350-pound male traveling with a female during the breeding season. He'll set up a 2-acre territory around her. He'll do the back rub on multiple trees and leave those deep sunken footprints, warning other bears that she's been taken. A few years ago, I started working with a different kind of bear. Starting in 2008, I went to China and I presented my work that I've done with the rehabilitation of black bear cubs and what it took to get a bear like Squirty that I could use as a research animal over the last 20 years. I went with a delegation of scientists, professors. They were interested in establishing relationships with China on climate change and other things. It was a trip to try to establish relationships. And when we got to the Chengdu Panda Base, I presented my work for the first time. I gave a talk like I gave you tonight, which is not scientific at all. And when I got done, Hu Rong, who's the director of science and research at the Chengdu Panda Base, came up to me and she said, "We noticed that your talk was quite a lot different from the other talks." She said, "You make us think." And then she was all over me like glue. I was immediately rushed off to the Department of Forestry to give my talk again. And it was several more years before I was invited back. It was in 2012. They had some questions about what I had presented to them. They were afraid that if they walked their pandas loose in the wild, the panda cub would run off. They'd lose an animal that was worth $1 million a year in rental fees to zoos, and they'd also, be considered a failure. And they were also concerned that the wild pandas would come down and attack their researchers. So we arranged for them to come and visit us in Lyme. They came to the English Learning Center at Drexel and drove up for an extended weekend. We took them for a walk. We had 30 cubs at the time, 6 were bottle feeders. We opened up the gates to the cage and took them for a hike with the cubs up on the hillside behind the house. The cubs were only interested in vegetation. They found hornets' nests. We took them to a red pine marking tree that still had bear scent on it from the breeding season. The cubs all climbed the tree, got very excited about bear scent, and they came off and they did that stiff-legged walk, marking little drops of urine. Hu Rong exclaimed that they can communicate with the wild bears without even meeting them, and she got terribly excited. We went up that evening to my study area, and Squirty and a number of other wild bears came out. No bears attacked the truck. They got even more excited. They had a 7-hour ride back to Drexel. They talked the entire way back. The following March, our project started with 4 panda cubs. 2 would be control animals raised by their mother. 2 would be nursed by their mother, but socialized by, I selected a postdoc at Drexel who was there 24/7. We selected a group of Chinese keepers and biologists. We had to train the biologists and the keepers how to interact with pandas. One of the early complaints of the keepers was that they said that the pandas liked Jake, who was our postdoc. They liked Jake better than they like us. And the problem was that the Chinese culture hadn't had any pets, and they only saw these animals as objects in the zoo. And we had to explain to them that you have to treat an animal like it's a human, it's a being. And if they don't recognize that you have empathy for it, they're not going to like you. And as soon as they understood that and they were able to do it, things have worked out very well. The first 2 cubs are ready to be released to the wild. We've selected a release site at one of the panda reserves in China, and hopefully the cubs will be released this fall. And the next set of cubs are on their way. I'll end up quickly with a visual. I call it Houdini's Apple Tree Olympics, so hang on. And finally, his dismount. Thank you very much.